Writing and solving linear system word problems. We'll be writing linear systems in standard form to solve word problems. We'll be using the template x plus y equals a number, x plus y equals a number. An office supply company sells two types of fax machines. They charge $150 for one of the fax machines and $220 for the other. If the company sold 22 fax machines for a total of $3,900 last month, how much of each type were sold? So we're going to define the x and y variable, write two equations involving x and y, solve the system, and check the system. So we're going to first define x and y. But before we do that, I went ahead and highlighted important information that we're going to use to solve the problem. $150 for one of the fax machines and $225 for the other fax machine and $3,900 for how much they made last month all deal with money, so I highlighted all those numbers in yellow. Another number that they gave us was 22 fax machines, and so I highlighted that in a different color. So first we need to define x and y. In this instance, x will be considered the first fax machine, or the one that we're charging $150 a month, and y will be the second fax machine, or the $225 we charge a month. So now we need to write the two equations involving x and y. So again, we're going to be using our template x plus y equals a number, x plus y equals a number. So let's first look at the highlighted yellow. So all these deal with money. So we know that $150 times X amount of fax machines plus $225 times Y amount of fax machines equals $3,900 in sales last month. So we're going to write all those numbers in one equation. We also have this 22 fax machines were sold. So we know that a number of X machines plus the number of Y machines was 22. So now we've written our linear system. Step 3, we're going to solve the system of equations. So I'm going to substitute. I'm going to isolate the y in the second equation, and that's going to give me y equals 22 minus x. And I'm going to use this number to substitute back in the first equation, which I did right here. I solved for x and calculated that to be 14. I solved for y and calculated that to be 8. Now step 4 is to check the solution. $150 times 14 machines plus $225 times 8 machines equals $3,900. So that works. Also, 14 $150 fax machines plus 8 $225 fax machines. 14 plus 8 gives me a total of 22 fax machines. Next example. There were 350 student and adult tickets sold at the performance of Cinderella. Each student ticket cost $5, and each adult ticket cost $7. If there were $2,190 in ticket sales, how many student and adult tickets were sold? So step 1, we're going to define our x and y variable. Then we're going to write two equations. We're going to solve the system and check the solution. So we're going to define the x and y variable. X is equal to the student tickets and Y is equal to adult tickets. I went back and highlighted information. There were 350 student and adult tickets sold. Also, we know that the student tickets cost $5, the adult tickets cost $7, and that or equaled $2,190 in ticket sales. So now I'm going to write the two equations using this highlighted information. There were 350 student and tickets sold. So x plus y is equal to 350, the total amount of tickets sold. I also know that each student ticket was $5. I sold an X number of those. and each adult ticket was $7. I sold a wide number of those, and together we made $2,190 worth of ticket sales. So there's my system. So now all I have to do is solve it. So I'm going to solve it again by substitution. I'm isolating my y. That's going to give me 350 minus x. I'm going to substitute that into my next equation and calculate that x is 130 and y is 220. When I check my solution, I see, in fact, that is true. 130 plus 220 is 350 tickets, and 5 times 130 plus $7 times 220 is $2,190 in sales.